Explain functionality of polymers. Generally, the functionality of molecule equals the number of reactive sites in a molecule. The reactive sites in a molecule refer to those bonding sites where functional groups like hydroxyl group, carboxylic group, amine groups can be attached. In other words, it can be stated that a compound assumes functionality because of the presence of reactive functional groups. And the number of functional groups present in a compound defines its functionality. Some compounds do not consist of any reactive functional groups, but it does not imply that these compounds do not possess functionality at all. The presence of double or triple bonds in the molecules of these compounds makes them bifunctional or polyfunctional. Let's consider some examples to understand the concept of functionality. In alkene monomers, the double bond can be considered as a site with two free valencies, and when this double bond is broken, two single bonds become available for combination, giving them bifunctionality. Acetylene, on the other hand, has a functionality of 4. There are some other compounds in which functionality is imparted by the presence of easily replaceable hydrogen atoms. Consider phenol, for example. We know that it consists of OH group as functional group, and when this is replaced, phenol exhibits monofunctionality. But phenol can also undergo substitution reaction at 3 sites, replacing its 3 hydrogen atoms and hence exhibiting a functionality of 3. The functionality of the monomers used in a polymer change gives an idea whether the polymer formed will be linear polymer, branched polymer, or 3-dimensional cross-linked polymers. If bifunctional monomers are used, then generally linear polymer is formed. Whereas if trifunctional monomers are used, then cross-linked polymer is formed.